Hey guys, in this video we're going to look at how to calculate an empirical formula, and in particular we're going to look at how to calculate the empirical formula of the molecule caffeine. Now this comes from a supplied version of the old 2.3 standard, and in this question you're asked to calculate the empirical formula of caffeine, and the information you are given, the percentage compositions, is that caffeine contains 49.5% carbon. It also contains 5.20% of hydrogen. It also contains 0.9% of nitrogen. And finally it contains 16.5% of oxygen. Now remember, when we're calculating an empirical formula, what we're doing is, because we're dealing with percentages, we're going to assume that we have 100 grams of caffeine. And because we have 100 grams of caffeine, we can convert the percentages of each element into the amount of mass. We can just assume that the mass of each element is exactly the same as the percentage. So what that means for us is that our mass of carbon is going to be equal to 49.5 grams, and that our mass of hydrogen is going to be equal to 5.2 grams, and our mass of nitrogen will be equal to 28.9 grams, and finally our mass of oxygen is equal to 16.5 grams. Cool. Now obviously the next piece of information we need is our molar mass, and we get those from our periodic table, and I'm just going to assume that you know those, hopefully now at level 2 chemistry, for these four elements in particular. So I'm just going to go ahead and start to calculate the next step, which is to do the number of moles for each element. So I'm going to start with carbon, and our number of moles of carbon is equal to the mass, which is 49.5 grams, divided by the molar mass, 12.0 grams per mole. Now, if we put that through a calculator, we get an answer of 4.125 mole. Nice and easy, we're just doing N equals M over capital M. So with our hydrogen, we do the same thing. The number of moles of hydrogen is equal to the mass, 5.2 grams, divided by the molar mass, 1.0 grams per mole. And we get a nice easy answer there, 5.2 moles divided by 1. Moving on to our nitrogen. Number of moles of nitrogen is going to be the number of moles of nitrogen equals 28.9 grams divided by 14.0 grams per mole. And putting that through a calculator, we find out that we have 2.06 mole. And finally, we want to do the number of moles of oxygen, and that is equal to 16.5 grams divided by 16.0 grams per mole, and that works out to be 1.03 mole. So that's ace. We've now worked out the number of moles we have of all four elements in caffeine. Now remember, the empirical formula is basically a ratio of atoms in the compound. So what we need to do now is take these numbers of moles, and we want to use them to figure out what the ratio of elements is. And remember, the easiest way to do that is to divide by the lowest one. So in this case, our lowest one is oxygen. Has the lowest number of moles, it's 1.03. So what we're going to do next is we're going to take each four numbers of moles and we're going to divide by 1.03. So I'm just going to go ahead and do that right now, just where we've got our answers. We're going to divide by 1.03. And we do that, we're getting a ratio. So we find, obviously, for oxygen, 1 divided by 1.03 is 1. For nitrogen, it's 2. For hydrogen, it works out to be 5.04, so we're just going to round that to 5. And then for carbon, 4.125 divided by 1.03 works out nicely to be 4. And so that is our ratio of elements. Just to remind us what we've got here, we've got carbon, hydrogen, nitrogen, and oxygen. So our empirical formula is equals C4H5N2O. Nice and easy. Now, often in these sorts of questions you might get given a molecular formula and be asked to work out what the molecular formula is. Well, in this case this question does exactly that. We're told that the molecule has a molecular mass, so a molecular mass of equals 194 grams per mole. So what is the molecular formula? What is the molecular formula? Alright, we can work that out quite easily. First thing we need to do is take our empirical formula and we need to work out what its molar mass is. So, it's basically going to be 4 times 12. So the molar mass is 4 times 12 plus 5 times 1 for hydrogen plus 2 times 14 for nitrogen and plus our 1 oxygen, 16. And if you do the math on that, you work out it equals 97 grams per mole. So our empirical formula up here, just let me get a different color, let's go with this nice reddy color, yeah? So what that means is up here our empirical formula has this mass here, 97 grams per mole. But we want to know what the molecular formula is, which has 194 grams per mole. It works out to be quite easy because all we want to do is divide 194 by 97. So if we go 194 divided by 97, it's going to give us 2, which is nice and simple. So all we have to do is multiply the empirical formula by 2, and that's going to give us our molecular formula. So our molecular formula is going to be C8H10N4O2. That is our molecular formula. Alright, and as we can see, that's nice and easy. It's just double our empirical formula. Our empirical formula has a mass of 97, which we calculated earlier. If we double that, it gives us 194. So we just have to double the numbers in our empirical formula, and we get a nice molecular formula of C8H10N4O2. Hope that was easy to follow. This is my first video. I apologize for my awful messy handwriting. If you have any questions, please leave me a comment and I'll try and fix things up for you. Cool.